right, hello everyone. I'm just trying to center myself a little bit between on this very large stage. Welcome. I know I've already been introduced, so I will start by saying I have been really intrigued by this question for a long time. How do I optimally break my UI into queries? And more specifically, this question for me has been, what should the scope of my query be? And so I've had a lot of conversations with my fellow engineers around this, and we haven't always been able to come to the most clear conclusion. So I'm hoping our time together will maybe illuminate some of those problems and also get us closer to a bit of a solution and answer to this question, and also hopefully help paint the picture of why this question matters in case this is not one that's running around your head. And I'm kind of wondering if most of us here are more on the front end. I don't know, but that might be. I know my whole career has been on the front end. So we're going to jump in, I think. There's only 2 buttons on here. Ooh, it's finally working. Okay. So this is a story I'm going to be sharing with you all. It's my story, but almost more than that, it's other people's stories. And that's because I work in an organization of 2,000 plus engineers. So in large part, I'm working in libraries that other people have built. And so I did make sure to sit down with some of them, make sure I'm saying things correctly, got their approval on some things, and you'll see their names at the end. So this is kind of a story from the perspective of many engineers. This is also a story of components, because our UI usually exists in what we think of as components. If your organization, though, is anything like mine, you frequently have this conversation. Exactly what is a component? So our components regularly go through existential crises. This is also a story of design systems. There's our design system logo, EGDS. Our design system goes back to about 2017. So our tremendous engineers have had a lot of time assembling that, and this is also a course of data, because we're talking about queries. What should the scope of my query be? And I would say in order to answer the primary question, it's going to be a set of questions I'll present. I believe all of these questions exist at the intersection of design systems and data. So I'm going to get into just a little bit of design system thinking later on. This is also a story of organizational realities. You'll see that play out in the first use case that I share with you. Yeah, so this is the story of EG, optimally trying to break our UI into queries. And I should also add, our schema goes back at least 4.5 years. So we've had a lot of time to try to marry these two appropriately. But I want to share that we definitely do not have all the answers. I'm going to highlight some things where we're really not very clear, and I think they're very interesting problems. And I also look forward to hearing your thoughts, your stories, and your experiences later. Primarily what we'll be going through is 2 use cases, and then 3 theories. And then, of course, all the learnings from those use cases. All right, so if we look at the property details page of our lodging line of business, and I said, let's play a game together, can you find the component? Could you do that? Of course, the answer is no, because components are completely arbitrary. So I'm going to break it down for you. If we run a very simple script, you'll see that there's actually 607 components on this page. And I should highlight that this page is actually 5 times longer than what you see there. I should also call out that this is a particular type of component. This is what I'm going to call an atomic component. And when we get into design system thinking, I will talk more about that later. The other thing I want to highlight is that if you look at this real closely, you may note that some of these components are nested inside of others. And that's not the only kind of component here. We also have things that I call pattern components. You can see I've highlighted 4 of them. There's more than that there. But the point is that there's more than just 607 on this page. So as I think we all know, our industry's been changing. We no longer think in terms of pages. Instead, we think in terms of components. And I am using the Russian nesting doll analogy because, of course, as we know, components can nest. We also no longer think in terms of buckets of data. Instead, we think in terms of, well, whatever you want. You can have exactly the data you want, as much of it as you want, or as little, which really begs the question, do you know what you want? Which gets us back to components and the original question of this topic, which is, how do I know the scope of my query? Okay, so this brings us into some more interesting questions. One is, because components can nest indefinitely, at what level of nesting do we associate data with a component? Is it the whole screen? Is it later on? If you're like me, at some point you say, well, how far can you nest? What's optimal? What makes for a good architecture? Another question is, when do I power multiple components with the same query? This was something I was hitting as I was coding some of our components, and I was like, oh, they look awfully similar. Should they be powered by the same query? My major question is, how do I determine the scope of my query? Should it be the whole screen? Should it be the chunks of the screen, which are obviously different? And I put obvious in quotes because what's obvious to one person is not obvious to another. Is it whatever the designer says? That's what I thought was the answer for the longest time. I thought when I got that Figma from the designer that they had already had all these conversations and they knew where a component should start and end on a given screen. But after a while I realized they're not trained in GraphQL, just like I'm not trained in design principles. Is that whatever product says? Well, that's the same limitation. They're not trained in GraphQL. So just a recap of the questions that have been running around my brain for a couple of years. At what level of nesting do we associate data with a component? When do I power multiple components with the same query? How do I determine the scope of a query? And like I called out earlier, I believe all these questions exist at the intersection of design systems and our schema. So I'm going to hop into just a little bit of design system thinking. All right, so I went out to Nielsen Norman Group. I think they're probably the premier UX organization. And this is how they define design system. It's a set of standards to manage design at scale by reducing redundancy while creating a shared language and visual consistency across different pages and channels. If you're like me as an engineer, basically this design system is, oh, it's a library where I get a bunch of buttons, right? That's generally how we think of it, but this is the more comprehensive idea. And then I would say that there are three kinds of components in my head for the purpose of this talk. So I just want to add that caveat in there. So I'm about to show a paradigm. This is basically a design system in action. And you can use different terms for these things. These are the terms I'm going to use just for the purpose of this talk. I'm not saying these are the right terms. I'm not sure there are right and wrong terms. And I'm not even saying this is what my company uses. But just so you know what I mean when I use these terms, here's the paradigm. So these aren't just three kinds of components. These are three levels. This is a hierarchy. So there are atomic components. We already saw that. You saw those 607. The concept here is that this is a kind of component which you cannot break down and reassemble in any other way, right? This is how our designers enable us to create consistency in our UI. We can assemble our atomic components together and get pattern components. These are, again, comprised of atomic components, but they have a very specific purpose. They are built around a user, task, or problem. And then finally, we can assemble our pattern components together and get your layout component, which should have layout instructions in it. So this is a paradigm in my head. These are the terms I'll be using. I'm not saying this is the right way. I think another interesting thing is saying how many levels you can have in between there, because why not? As long as you're getting efficiency in what you're building, you could have atomic components inside of atomic or pattern inside of pattern. But when I use these terms, hopefully now you know what I mean. At my company, we like to debate all these terms all the time, so they're highly entertaining conversations. Before I get into the two use cases and then the three theories, I want to present just a diagram of product complexity. This is not an architecture diagram, but I bring this up here because depending on the product you're building, you'll just have very different needs and you'll have different challenges. So probably like a lot of you, I Google every single day, and frequently I've been, in the past, I was Googling various GraphQL schema best practices, and so I'd run into a lot of Airbnb articles. They've been doing tremendous work in this space, and I realized slowly as I was reading their articles, their use cases, what they're learning, that they only have one product. That means they're facing different things. So my company, you'll see, has more than one. So I'm just gonna display this diagram, and it directly affects the first use case I show you. So I just wanted you to have this background first. So like most companies, our single federated schema is powering web, Android, and iOS, so 3 different platforms. And then we have all these products. This is not a comprehensive list. I'm not in product. It's something like this. So don't screen cap that. So the idea is I'm demonstrating permutations, what we need to support, right? If we go to, say, just the first brand, Expedia, what what products does it have? Well, it has stays. This is like hotels and things. Stays, flights, cars, cruises, things to do. As far as I know, I'm not in product. As far as I know, we've got 5 products, not 1. And so these are the permutations that we're building. So yeah, so we looked at platform, brand, and product lines. Finally, this is just kind of a curiosity, doesn't apply to our topics today, but this is also in 57 different locales. But what I want to highlight are those product lines. Keep in mind that there are 5 of them. Okay, so now that we have all that background behind us, design system thinking, and kind of the general questions I think would be really valuable to answer, let me show you the 2 primary ways we've chosen to answer these questions, and then the things we learned from them. So most of our screens takes the following approach. We have tied one query to one component, and we thought that should be a good time, right? Because if you go out to, say, Apollo GraphQL, they say each component can and should query exactly the fields it needs. Or if you go to, say, GraphQL, they talk about constructing a query for a component. The point is that all the major players assume that you're connecting a query to a component. No one says page, right? And then, Apollo GraphQL here points out that even React, the language itself, encourages associating a query with the subset of a screen. So there's kind of a picture of our library. So we essentially built a library. This is a library of hundreds of components, each component attached to its own query. What could go wrong? Here is our activity reviews component. So this tells users all the review information it needs for our activity product line. Then we build another one. We have our property reviews component. This tells a user all the review information they need to know for the property product line. We built the same thing twice. If you come out to another component, we have a sailing card. So this is our cruise product line. It's just offer information. We build it twice, once for cruise and once for our property product line. If you come out to our map triggers, so this is a little piece of the UI. When you click on it, you get a full screen map. We build it once for cruise, once for property, and then another time for another section of the page called trips. I'm hoping this bloat is making my point for me. This screen should also kind of highlight another point. If a designer was looking at this, I think they would immediately say, hold on, we have such big inconsistencies here. So another thing to note, when there is this much bloat in a system, it opens the door to inconsistency. If we were to only have built this component once, like we should have, that inconsistency wouldn't even be possible. And my favorite one, here's all of our carousels. We built one for cars. We built one for properties. We built one for trips. We built one also for properties, another one for properties, which is stays. Stays is like the official term, I believe. We built an activities carousel and a cruise carousel. So I think we built the same thing 7 times over. And this is just a small example. There's much more that I could show of what we've done. And that's only in the UI. That's only bloat, redundancy, duplication in the UI itself. Each of these individual components is tied to its own query. So as much redundancy as we have on one side, we have on the other. So we have our activity reviews query, but we also had to build a property reviews one, right? Because they're 2 separate components. So there we have our own redundancy, and it continues for all the redundant ones you saw before. So before I get to the takeaway here, I just want to call out that I work with amazing engineers, and this problem has been known for a while, for a couple of years. So there are multiple projects underway to fix this, but it's a really big fix at this point. So I just want to give props to my fellow engineers who are working on this. So the learnings are that defining a component as something tied to a product line bloats our UI code, bloats our schema, and opens the door to inconsistency. So making components product line agnostic is definitely the takeaway. Another thing we could say about this is that we basically misdefined component. We didn't conceptualize that well enough. It was, for us, tied to a product line, but I think if we abstract one layer up and if we just tie it to a task, what the user is doing, then most of this would have gone away. And one of the theories I'm going to talk about at the end really gets into that. You could also say that this was an example of not separating on the right concern. We separated based off product line. And that was really pretty logical because we used to work in design and development silos per product line. So, of course, we started building flights components and cars components, et cetera. And then that bloat flowed down to our schema. And I should call out, I only showed you web components. I assume the same bloat and redundancy is also occurring in our Android and iOS repositories. Okay, so that's our first use case. Our second use case is a totally different part of the UI. These are our trip screens. Users come here just to see their previously made purchases. So looking at upcoming flights, lodging reservations, and things like that. Before I show you this very, very different approach that this team took, I should highlight that there was an individual problem they decided to tackle with this, which wasn't in the mindset of the people doing approach number one. So it's a very, very ambitious goal they had. But they looked at this problem we have, and this problem is best understood by thinking of this question. How long do you think the slowest to upgrade Expedia Group customer takes to upgrade their app? So one of my fellow engineers ran a Splunk query, and the answer is 1 year. Since we have Android, iOS, web attached to the same schema, it doesn't matter how fast a web can update, which is like every second. We have to maintain those previously named types, all those fields. We can't just rename them when we want. We have to maintain all the way back to a year, which then means we can't really we can always add new features, but in terms of refactoring an existing feature on an existing app, that's going to be a problem. Either we screw over some of our users and their app starts breaking, or we just explosively bloat the schema and just add as many new types as we need every time we need to make a change which involves renaming a field. So to get around this 1 year problem, this team said, hey, what if we took a totally different approach? So if you just focus on that middle column, you'll note that what they're doing here is building the most generic components you can think of. So every one of those components could do like anything. And then that means the back end can drive just about everything. In fact, they decided that we're going to have one query for the whole screen. So that means the back end, because the data continues flowing, whether it's web or native, can even rearrange the whole page. It's almost like you can get a whole new page based off the data. So that's how we were going to get around this 1 year limitation. So the approach here was one query plus one screen. That should give us some server-driven awesomeness, right? And I should just mention, so you know, a trip from the perspective of Expedia is just pretty much anything you can buy here. This is the trips part of our UI. So that means in this particular approach, we're already product line agnostic. So that's great. We're not making the mistake you saw in the first use case. But we are doing something very different. And we're saying the server can drive which components appear and in which order. And every single screen is attached to its own query. That allows that one query to basically do everything. So we can get around that 1 year limitation. And what could go wrong? Well, if we look at this original mock-up, this came from some designers and product, I believe. This is before any code was built. You can see this is a very simple UI. And I believe they specifically targeted this part of our UI because, of course, there's always the possibility for performance problems if you're going to tie one query to one screen. So we just said, hey, trips is really simple. Let's try this approach here. So we did, and here's our first iteration. You can see it's already got more stuff on it. And finally, when you get out to desktop, we were adding maps. And essentially, over time, product and design kept wanting to add more things, as they should be able to. It's their product, right? And queries got too large. So the query string itself was the problem, not the payload. And let me just back up for a second. Basically, if you remember, those components are so generic. That means they can support like every possibility. So that means there were so many fragments going into to build this one single query. So out on the abstract syntax tree, so this is what's being built on the GraphQL server at one point in time. We went from 193,000 lines and 10 megabytes to 700,000 lines and 47 megabytes, and we had various instances running out of memory and falling over. This is a worst case scenario. I'm showing you the absolute worst to make a point. But if you notice, well, okay, our response time also, we went from 8 to 30. But if you notice, that baseline that we're comparing to, it wasn't even good. So the learnings we got from this approach was that tying an entire screen to one query will eventually produce performance problems, even though there's a great goal we were trying to achieve. It was a good try. And building an architecture that blocks fundamental flexibility is unwise. We were basically telling product and design, don't add more stuff here. So the takeaway is to tie a query to a component. And of course, a component here meaning a subsection of the screen, because you could define a component as the whole screen. So I want to make that very clear. All right, so a few unsolved challenges that I can think of in terms of what I presented so far is that given that we cannot performantly populate an entire screen with one query, how do we solve the problem of the slowest upgrade app user? Or put differently, can we find a way to allow the server to dynamically select components and choose their order? OK, so I will recap some of those learnings in just a little bit, but kind of looking more towards the future, here is some of the theories that I particularly wanted to present. And the first one is related to really the title of this presentation. And I think the title was, how do I optimally divide the UI into queries? So another way of putting that is, what should the scope of my query be? And so here is my proposal. I think that these are totally untested. These are just theories. So I'm curious to hear your theories later on. But I think it makes sense to attach a query only to the pattern component level of a design system defined specifically as follows. So again, we're answering the question, what should the scope of a query be? So I'm saying attach it to a pattern component. And this is a component which solves a usually reoccurring user problem without reference to product line, platform, or brand. So I'm going to break all that down. So a user problem, if we are really focused on a user problem at this part of our design system, that means, OK, we're thinking from the user's perspective. This requires product or design input. Also, another implication of if we're revolving around the user problem is that when you think of users, when they're coming to our site or our app, they don't come to click buttons. But they do come to research a trip to Las Vegas. So that means this component needs to be at that pattern component level within our design system, not an atomic component. If you think about atomic components, they're really just mechanical realities. They're essential, they're important, but their purpose is very different. I think from the pattern level on up, we're talking about thinking from the user's perspective. We're talking about meaning, right? An individual component carries, or atomic component carries no meaning. Another part that we should dig into is this should be a component which is usually reoccurring, so it's reusable. I think this is very well known, very understood. If we looked at that definition of what a design system is, that included the idea of reusability. So this is something our designers are all on board with, right? It's got to be reusable in most cases. And then, of course, because full pages and screens are not reusable, we're definitely excluding that, right? So we're saying a query should be attached to something which is smaller. And then that has that great benefit of this can be dragged and dropped across our whole site. You have this reusable module where it's not only the UI, but it knows what it needs to know, like it knows what data it needs. And then finally, if it's without reference to product line, platform, or brand, then you avoid that bloat, which I showed you in our first use case. So yeah, that's my proposal. It hasn't been fully tested. So that is my first theory. And the second theory is directly tied to it, because if we're saying all of our pattern components need to be about solving a user problem, the question then is, what are all the user problems? So I'm suggesting here that it makes the most sense to use task modeling as the backbone of both the UI and the schema. And I'll get into task modeling in just a minute. But the purpose is to know what pattern components we need, which in turn tells us what queries we need. So in my head, I'm not in UX. Task modeling is usually considered a subsection of the UX discipline. In my mind, this is how this could play out. Again, this is a theory, it's not tested. But the idea is that one task can be generally interpreted or becomes a single query. And that one query, of course, powers a single pattern component. Ideally, this would happen before all else, including design, because this should be informing design of what components we need. I remember sitting down with a designer one day and I was asking, okay, how do you know where a component ends and starts and ends? And she said, I know it when I see it. So just like development needs a more concrete answer to this, I think design would benefit from that too. So the result is not only, this should be updated, I never got around to updating this. The result would be not only a controlled schema, but also controlled UI code. We currently have significant bloat in our UI code because maybe we didn't have time to work through all of these ideas. So it's going to be not bloated because we're not thinking in terms of product line, we're thinking in terms of tasks. So it's an abstraction. I don't care if it's flights, I don't care if it's cars, I don't care if it's pizza. The user is doing a particular thing. What are those things? And then the schema itself should be navigable. For us, this is an issue because it's a really big company with a really big product. We have over 5,000 types. It'd be nice to get that under control. And then also the schema itself becomes user and client focused. I'm pretty sold on the demand oriented view of the schema, and so that's what we're searching for here. The last thing I should call out, oh, okay, so here's an example of, like a kindergarten level of a task model. So compare offers, filter results, understand geographic context, etc. Just to give you an idea. All these things would start with verbs. These are things the user is doing, right? The last thing I should call out about this theory is that it facilitates creating a shared language. And I have read about this a couple times. It's really, really excited me. But if you go to GraphQL, they'll say something like, think of your GraphQL schema as an expressive shared language for your team and your users. That sounds really noble and really helpful, right? And then also, if we come out to this other gentleman who posted on Medium, he says, your schema should promote a common product language that engineers, designers, and all stakeholders can use to discuss and iterate on complex concepts. And I was like, yes, that's brilliant. Communication would be hard. What I've noticed since reading these things is I've never found an article that tells you how to do this. And so my proposal here is that the act of task modeling itself should be that endeavor, right? So if product, design, content strategists, and engineers all got together and they constructed that task model together, that would be the event during which you come up with that shared language. And then it acts as the backbone of your queries and your pattern components, which should be one-to-one. Okay, so those two theories are very related to each other. This last theory is kind of on its own theory. It's my last one to give you. But I'm really excited about this one. So I'm going to come back to that question in just a second. But I need to paint a picture of the problem here. So if we look at a couple of pattern components, you can see they've got their own queries. One of my fellow engineers was telling me that, this approach is great. We know this is the way we're going. But when you have a really long page, remember I said this page is like 5 times longer than what I could fit on there? When you have a really long page and say all of those queries are hitting the same GraphQL service, that can create performance problems. So there's other problems to solve, once you take a new approach, right? So this particular theory relates to that. And so again, only a theory, not tested. But we are looking at creating something called an experience container. And the idea here is that once an individual screen loads, all of these components will register its queries to the container. So the query and the components are still tied together. They're still like drag and droppable, right? We can use these in different contexts. They still know the data they need. But once they're inside that individual page, they're not executing their query. It's like hold off, right? Pause. Instead, everything is getting relegated to that parent, the experience container. And it should have, again, this is a theory, it's not all developed, but it should have enough intelligence, A, to know what all the queries are on the page, and B, to navigate between some logic. What will be my best, we'll probably be doing batching, query batching here. What will be my best batching approach to use? Okay, so takeaways would be make components product line agnostic. I hope my company has demonstrated very well how not to do this. And then also attach queries to components, not screens. And finally, I would love to hear your experiences. I think this is a really interesting problem space. So your theories and your use cases. Last, I just want to give thanks to a lot of engineers who helped me out. So Amanda, Chris, Matt, Frank, Jay, and the best mentor ever, Adam. Yeah, and I'd love to hear your feedback. Here's my topic table if you want to come to a more official time. But I will go back one screen because your feedback is really important to me. So thank you so much, guys.